Bismillahirrahmanirrahim. Assalamu alaikum and good morning to my students. Welcome to the second session of our lectures. I am going to start the second part of this book from ninth chapter. Okay. So it is all about. I hope that you have enjoyed the first session of this book, and now I'm going to start second session of this book. It is all about what it is all about: sequence and series, sequence and sets, sequence and series, or sequence and sets, whatsoever you call it. So let us start. Now, my dear students, what is a sequence? Sequence. Now this is a sequence. You see, one. This is a simple counting written 1, 2, 3, 4, 5. What is happening over here? That we are keep just adding 1, 1, 1 and 1 and so on and so forth in each of the previous element in this row. Okay? If I add 1 in 1, then we'll get 2. 1 in 2, we get 3. 1 in 3, we get 4, and so on and so forth. So that means this line, this sentence is written in a special sequence in which the increment of each element is 1. In which the increment of each is 1. If we keep on adding this increment to the previous element, of this sequence, then we'll go on simple counting form: 1, 2, 3, 4, 5, 6, and so on and so forth. And for example, if I do it in this way: 2, 4, 6, 8, 10, and so on and so forth, you see that the difference between the two is 2 and 2 and 2 and 2, same. So what is the increment over here? 2. For each next part of this sequence, next element of this sequence, we have to add the increment to the previous term. Now this is the previous term or the first term. This is the previous term. When you add this 2 to this 2 or the first term, you get 4. Now this is the previous term. Okay. When this is the previous term, you add 2, you get 6, and so on and so forth. We are getting an order of even numbers. We are getting the order of even numbers. Now, what is a sequence? Let me define the sequence. Now, sequence can be thought as a set of whose items in the list have been listed in particular order. Now you see that this has been listed in the particular order. The increment over here was 1 and the increment over here is 2. And even if I write the odd numbers, you see, if I write the odd numbers 1, 3, 5, 7, 9, and so forth, the increment again will be 2 over here. Okay. So this is the special order in which each item is written in such a way that the increment remains the same. Increment remains the same. You see, here it is again same. Here it is again same. Now what is this increment called? Let us discuss about it. Now this was sequence, and if I say sets, the group of particular things, the group of particular things. For example, the things or the furniture, you can say the things or furniture in the bedroom. The bedroom furniture. What we have here is, of course, a bed, okay, a side table, okay, maybe a lamp, chair, and so on and so forth. Now, this is a group of things which you can find in a bedroom. So, if I just enclose it in curly brackets, if I enclose these set of things in a curly bracket, then it is called a set. And if we go to the numbers, the set of even numbers, you can also say it first 10 even. Now let it do it like this. First 10 even numbers. Okay, now it will be A, or you can say it E, because it is even number. Put a curly bracket over here. When you start a set, it always starts from a curly bracket. Sometimes the parentheses are also used. Okay, now E is first 10 even numbers: 2, 4, 6, 8, 10, 12, 14, 16. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now are this is the set showing the set of even numbers, first 10 even numbers. You can say first 10 even numbers. So you see that again, if I just decompose it, you see that the increment is always 2 in between this set. So there is a special sequence in this. There is a special sequence in this set, that the increment of each term is plus is 2, 2, 2, 2, 2, 2. Okay, and this is the main difference between set and the sequence. Because now if I just erase this, now it is a sequence. Okay, prior to that it was set like this, and also the name of set was written over here, sequence. Now this is a sequence of even numbers. Now each of this is called term. Each of this is called term. Okay, now this is called term. This is term, this is second term, third term, 4, 5, 6, and so forth. Now these are terms: 2, 4, 6, 8, 10. First term, second term, third term, and so on and so forth. And when this is term, and this is also term, this is also term, then the increment between them, when we have to find, we have to establish a relation which is called term to term rule. We'll establish a relation which is called term to term rule. Term to term rule. Now what we have to do is, we'll subtract the first term, the previous term, or you can say first term or the previous term from the preceding, from the next term. First term from the next term. Now what is the next term? Here it is 4. We'll just subtract it from the previous term, it will get 2. And again, for example, this is the first term, this is the next term. So 10 minus 8 is 2. You see that equal amount of increment, we are getting an equal amount of increment in each of the following terms. In each of the following terms. So that means that this relation term to term, term to term, term to term, term to term must be same. Must be same. Okay. Let me proceed. Let me take another example. Now you see the increment. I am using the word increment. But what if the case is like this? You see, one. Now, my dear student, this is again a sequence. Now, what is happening over here? The terms are decreasing. I have told you in my first session, in some lecture, that when the denominator is increased, here the denominator was 1, when there is nothing in the denominator, that is supposed to be 1. Okay, that is supposed to be 1. Okay, now it has vanished. 2, the denominator has increased. That means when the denominator is increasing, your number is decreasing. Prior to this, it was 1, now it is half. And in the third term, it has decreased to 1/4, it has decreased to 1/8, and it has decreased to 1/16. Now, how can we find what is the sequence in between them? Now, what is the term to term rule now here? What will be the term to term rule? Now, for example, you see, if I apply the first rule of increment, what will happen? This is the next term, this is the first term for these two. Okay, let me apply the increment rule. So, what was the increment rule? Just subtract the first from the later. Subtract the first from the later. So, it will become like this. So, taking LCM, 1 minus 2, it will become minus 1 upon 2. Am I correct? Now, for the second one, this is the first term, this is the later term. So, subtract the first term from the later term. It is like this. Taking the LCM, 4 will be the LCM. So 1 times and 1 and 2 times is equal to 2. Now it will become minus 1 upon 4. Now you see, my dear students, that there is a difference between the two terms. So we cannot apply the increment rule over here. So what will we do? Let us find another way of solving this type of term. Okay. Now what is the situation over here? Now if I divide the first term with 2, it will become this. Okay. It will become this, which is the next term. Now, after retaining the next term, I again divide it with 2. I again divide it with 2. Now, this is a 3-storied flat. Now, what will we do is, we just do it like this. Now, we'll just multiply these two elements, and it will get 1 by 4. And again, if I divide it by 2, now you see, again multiplying these two, we'll get 1 by 8. And again, if I divide it with 2, it will become 1 by 16 and so forth. You might be feeling some confusion of doing like this. This when we have a three-storied flat over here. Now it is very simple to explain over here that the first term is like this and the second term is being divided by 2. Now it is divided by 2. Now you see, when I just said that when there is nothing written, there is 1 written over under the uh, under the number. When there is a whole number, that is understood that the 1 is written over under the whole number. So 1 by 2. Now if I just take it like this, it is divided by 2. Now changing the sign of division into multiplication, but we now this is like this. If I just write it in this fashion, so it is 1 by 2, and when we change the sign of division into sign of multiplication, the following thing is inverted. The following thing is inverted. So it will become 1 by 4. 1 by 4. Okay? Now don't be get confused if these are multiplying directly. So this is another sequence in which we have divided the thing with an equal amount. With an equal amount. What was the equal amount? That is 2. We have divided each term with 2. Now another example. Now you see, again we'll try right from the beginning. We'll just take the second term and the first term. Second term and the first term. What we do, 2 minus 1, okay, 1. And if I do like this, it is 2. The differences are not same. Both the differences in this and this are not same. Now this has come to be 2. Now this has come to be 1. And if I go more further, it will be increasing more. You see that the difference is not same. So what we do? The second method, 1 divided by 2. Okay, it is wrong again. It is 2. That means we have to apply the third. It is multiplication. So 1 multiplied by 2 is 2. Okay. And 2 multiplied 2 is 4. Okay. And 4 multiplied 2 is 8. And 8 multiplied 2 is 16. Now here what has done? We have been multiplying it with 2 at every place. We have been multiplying it with 2 at every place. Okay, my dear students. Now the last example. Now you see that this is a common alphabet. Okay. Now this is also a sequence. 26 letters in a row. A, B, C, D, E, F. Okay. And if it is written like this, sometimes you have to hide something from another. So what we do, we establish some special codes. Like I say A, then I Z. I say B, then Y. You see, now this is again being establishing a special code. The first letter of the alphabet, the last letter of the alphabet. The second letter of the alphabet and the second last letter of the alphabet. Now this is it is being establishing. It is building a new code, some for some code words. Okay. Now let us start exercise 9.1, and then we'll draw a diagram to show how the each of the following sequence continue and find the next three terms in each case. It is very easy. I just told you exercise 9.1. Okay, question number 1 and part is A, or yes, A. 5, 7, 9, 11, 13. 5, 7, 9, 11, and 13. Now you see that there is increment of 2 in each term. Now this is term to term rule. Term to term rule. Now what we have to find is, we have to find next three terms in each case. We have to find next three terms. Now if I just start from subtracting, if you don't get divided, if you don't get multiplied. Okay, so these three operands are working somewhere here. So let's try this one. Minus or subtraction. 7 minus 5 is 2. 9 minus 7 is 2. 11 minus 2 and 2. Now I have established a sequence in which there is increment of 2 in each term. In each previous term, you can say. Now what I have to find is the next three terms. Now just 13 plus 2 is 15. 15 plus 2 is 17. And 17 plus 2 is 19. Now these are our answer. This is our answer. Now next three terms are 15, 17 and 19. B part is same, and C part. Now C part, C part. But see what does it say? 3, 9, 27. 3, 9, 27 and 81 to 43. 81 to 43. Now it is obvious from the sequence. It is obvious from the sequence that if you subtract 3 from 9, it will become 6. And if you subtract 9 from 27, it will not be 6. So we have to rule out the operand subtraction or minus. So what we do here is, we are going to multiply it. We are going to multiply it with 3, because the next term is supposed to be multiplied with 3. Is supposed to be multiplied with 3. Let us check it. Don't make it confirm, okay? Don't make it confirm. Now 3 multiplied 3 is 9. 9 multiplied 3 is 27. 27 multiplied 3 is 81. 81 multiplied 3 is 243. So we have to find next three terms. Now multiply this with 3. Now my dear students, the next term be 729. Again multiply it with 3. Again multiply it with 3. We get is, it will become 2187. And the third and the final term, you can calculate it by yourself. Okay. Now next question, part D. Part D, exercise 9.1, question number 1.5 to 3.55. 3.5. This is point. Okay. 5, 6.5. And we have to find the next three terms. So my dear students, If I subtract this from this, it will become 1.5. So you see that 1.5 is the increment over here. Simple 1.5 is increment. Okay, term to term rule, applying term to term. Just subtract the previous term from the next term, you get 1.5 in each case. So just add 1.5, you will get 8 as the next term, 9.5 as second term, and 11 as the last term. So these three are the terms which are now. Now question number 1, part F. Part F says 13, 11. 13, 11, 9, 7, and 5. Now you see that there is decreasing. Sometimes it is increment and sometimes it is decreasing. Now you see the difference between here is -2, again -2, again -2. We have established the difference which is -2 in each case. So it will become 5 minus 2 is 3, 3 minus 2 is 1, and 1 minus 2 is -1. Okay, now this is our question number 1, part F. So my dear students, you can complete this question number 1. Find the next 3 terms in each of the following sequence and explain the rule you have used in each case. Now, a little different question number 2. Little, a very small uh, difference is there. Now question number 2, part A. You see that this is 1, -3, and what comes after it is 9, and what comes after is -27. So we have to establish some sequence in these terms. So my dear students, you see that if I multiply it with -3, if I multiply it with -3, multiply it with -3. Okay, when I multiply it with -3, it will become -3, and when I multiply again it with -3, it will become 9, because minus and minus becomes positive, and again with -3 it will become -27. So the sequence has been established. The sequence has been established, which is -3 in each of the following case, in each of the case, that it is being multiplied with -3. It is being multiplied with -3. So just multiply it with -3. The sign will appear as positive, and it will become 3, 7 times 1, 21, and 3 2 times is 6, 7 and 8. The next figure will become 81, and the next to this will become, since it is minus, the result will be -3 and 243. It is -243, and you can find the last term also. So what we have done is we have established a rule that it is being multiplied with -3, and the next 3 terms are these 1, 2 and 3 still have to be found. So my dear students, some more sequences are given over here. Let us try them, and then we'll finish our lecture for today. It is B, It is MO, means Monday, Tuesday. Okay, short forms are given for each day: Wednesday and Thursday. Now these are the short forms, okay, or you can say the abbreviations. These are the abbreviations: Monday, Tuesday, Wednesday, Thursday. Now you see that each day is increasing by one day. Of course, Tuesday comes after Monday, Wednesday comes after Tuesday, and Thursday comes after Wednesday. So, of course, Friday, Saturday, and Sunday are the next 3 days. So, as I told you, that there is also sequence. Now, question number C and D, I'm going to just finish this chapter A, C, this exercise F, A, C, F, J, O. Now this is a special sequence, as I told you, that sometimes we have to hide something from other. So you see that one letter is missing over here. One letter. See, say one letter. Now one letter is B. A letter is B. Now after that, C, D, and E. Two letters are being. What are these two letters? D and E. And then F, G, H, and I. Three letters are missing. And of course, here it should be four letters be missing: J, J, K, L, M, and N. So you see, four letters are missing over. So in the next, it will be five letters missing. O, O has come, and next four are O, P, Q, R, S, and T. The next is U. Okay. After U, six letters be missing: U, V, W, X, Y, Z, A. We have gone back to our initial position. V, V, W, X, Y, Z, A, and the next letter will be B. And so forth. Seven letters. So this has become a new term. And very interesting part is also ahead of us, and that is part D. 1, 2, 2, 4, 3, 6. 2, 4, 3, 6, 4, 8. And we have to find next three numbers in this sequence. Now let us try right from the beginning, uh, the increment term to term. Okay. Now here, if I subtract first term from the next term, it is 1. But if I subtract first term, now this is the first term in second case, and this is the next term, then our answer will be 0. Okay. So it means subtracting is not the solution. Okay, multiplication: 1, 2 times 2. Okay, and again we are not getting the logic. The division logic: simply on the very second step, this logic is again wrong. So what we do? We have to find a certain logic that satisfies this whole sentence written over here. Now, in my mind, I this came in my mind that why not to try that there is a position, there is a position logic hidden in this sentence or in this sequence. Okay, what is the position logic? Now, this is start from odd numbers. This is odd, this is even, this is odd, this is even. That means if I write, if I write 1, 2, 3, 4, 5, 6, 7, 8. Now I think you might be getting the exact thing from what I read, from what I have written over here. So you see that the position here is odd, here it is even, here it is odd, here it is even, here it is odd, and so on and so forth. So in fact, we have two separate two separate position logics, two separate position. Let me bifurcate. Now take only odds, odd positions, odd positions. Okay. Now the odd positions are 1, 2, 3, and 4. See, and 1, 2, 3, 4. Okay. And the even positions are 2, 4, 6, 8. Now, the last odd position over here is 1, 2, 3, 4. Now, this is the last odd position. Okay, this is the last odd position, and you see that the sequence we are getting is only one increment. 1, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, and it is obvious that the next would be 5. Now the next number will be 5 over here. Okay. Now it is turn for the even position, because first we have to do the odds, then we have to do the even. Now the even. 2 plus 2 is 4, plus 2 is 6, plus 2 is 8, and the next position be 10. So write 10 over here. Okay. And again back to odds. 1, 2, 3, 4, 5, and it must be 6 over here. So this is our answer. 5, 10, and 6 are the next three positions. So my dear students, time to say you goodbye. So see you next time in exercise 9.2. So till then, it's time to say you goodbye. Allah Hafiz.